All right, today in class we worked on equivalent ratios. So we started by looking at this problem. It says Andrea spent $2 to get 10 cookies at a grocery store. Brian spent $6 to get 30 cookies at a different grocery store. And I asked the class to figure out if these two are equivalent or not. But first we needed some background on what equivalent means. So equivalent ratios are ratios that have the same value when they're simplified. They can be turned into each other and look like each other. Some people think of them as the same or equal. They're not exactly equal because they might have different amounts, but they are equivalent to each other. So we are trying to figure out if these two amounts are equivalent to each other. All right. So a couple strategies that were shared. Okay, and you're going to see these strategies come up again. The first strategy, and I always start by writing them as rates. So $2 for 10 cookies. And $6 for 30 cookies. In the first strategy, we set them up as equivalent fractions. We say that they're equal to each other. When things are equivalent, we're doing the same thing on the top of the fraction and on the bottom of the fraction. So here, I know that I can get from $2 to $6 by multiplying by 3. I know that I can get from 10 cookies to 30 cookies by also multiplying by 3. So I know that these two are equivalent because they can, if I multiply the dollars by 3, I'm also multiplying the cookies by 3. Another strategy that people might use is finding their unit rate. Oops. There's a way to just clear the page. Okay. So over here I have $2 for 10 cookies. It might make more sense if I write it out like this. If I want to know how much one cookie is, I'm taking my money and dividing by my cookies, or dividing by 10. $2 divided by 10 is 20 cents. So over there at that store, it's 20 cents for a cookie. At the other one, it's $6 for 30 cookies. If I want to know how much one cookie is, I'm going to take my dollars and divide by 30. And that, if I type it in my calculator, $6 divided by 30, I will also get 20 cents for one cookie. So that is another way for me to tell that, yes, they are equivalent because I'm paying the same price for each cookie that I buy. Let's look at another example. Target was selling 4 t-shirts for $20. Walmart was selling 12 t-shirts for $48. And I asked the class to figure out if those two are equivalent. I encourage you to pause the video when I ask you to figure things out and see if you can figure it out on your own. So there's two strategies that you can use for this one. The first one is finding the unit rates. All right. So when you're finding the unit rate, you're finding what is the price for one. So here first we have Target. Target is charging $20 for 4 t-shirts. Okay, if I'm finding unit rate, I want to know how much one t-shirt is. How much is each t-shirt? Well, $20 for 4 t-shirts. That's $5 for each t-shirt. Let's try the same thing for Walmart and see if they have the same unit rate. $48 for 12 t-shirts. One t-shirt over here. So $48 divided by 12, that's $4 for one t-shirt. Are they the same price then? No, those are not the same. So I would say that they are not equivalent. We could also use the equivalent fractions strategy that we talked about before. So again, Target was $20 for 4 t-shirts. And Walmart was $48 for 12 t-shirts. When I'm using the equivalent fraction strategy, as I look at the numbers and see if there's anything I can multiply by to get to the other one. Okay, so I know that I can get from 4 to 12 by multiplying by 3. Let's see if that same thing works on the top. Is 20 times 3 48? So let's see, 20, 40, 60. No, 20 times 3 would be $60. So I know they're not equivalent because I'm multiplying the shirts by 3, but the money is not multiplying by 3. Let's look at another one. One person is running 20 miles in 5 hours. Another person is running 45 miles in 9 hours. Take a minute, pause the video, and figure out if those two are equivalent. All right, let's think about our strategies. So first, let's use that equivalent fractions one that we like to use. So 20 miles, 5 hours. And then over here, 45 miles, 9 hours. So let's say you want to use the equivalent fraction strategy. That means you want to find something that you can multiply or divide by to get to one from the other. Is there anything I can multiply 5 by to get to 9? I can't think of anything. And I don't know what I can multiply 20 by to get to 45. So that doesn't mean that they're not equivalent. That just means that that strategy isn't going to work for us. So let's try the unit rate strategy, the other strategy we talked about. I'm going to write it over here a little bit so I have more space. All right, the first person is going 20 miles in 5 hours. The unit rate is out of 1 always. How many miles did that person go each hour? All right, so I'm trying to get down to 1, so I know I'm dividing by 5. 20 divided by 5 is 4 miles. That person is going 4 miles in an hour. How about the other person? How far are they going each hour? This time we're dividing by 9. And 45 divided by 9 is 5. So I know that those are not equivalent because this person over here, or animal or whatever, is going 4 miles every hour, but this one is going 5 miles every hour. So they are not equivalent. Okay. In class, we then worked on the got it on the bottom of page 60. So I'd like you to take a couple minutes to pause the video, see if you can figure out the got it's on the very bottom of page 60, and then we'll go over them. All right, hopefully you have tried got it A. Pause the video if you have not to see if you can do it on your own. In this one, you could have used either strategy. So we had 36 t-shirts in 3 boxes. The other one, 60 t-shirts in 6 boxes. Are they equivalent? Are those the same? So let's think about our different strategies. So the first strategy, we're figuring out how much is in one box. Well, if we do 36 t-shirts split up into 3 boxes, that's going to be 12 shirts in a box. Over here, we've got 60 t-shirts split into 6 boxes. So that's 10 shirts in a box. Do they have the same amount in each box? No. So they're not equivalent. These are not the same. You also could have used the equivalent fractions strategy. I know that I can get from 3 to 6 by multiplying by 2. Is 36 times 2 60? No, 30 times 2 is 60. So it is not a times 2 on top. They are not equivalent. Okay, you're multiplying your boxes by 2, but the t-shirts are not multiplying by 2. Pause and do letter B if you have not done B yet. 42 flowers, 7 vases, 54 flowers, 9 vases. So some of you like to use the equivalent fraction strategy first. That strategy doesn't work here. There is no whole number that I can multiply by there to get from 7 to 9. And there's no whole number that I can multiply 42 to 54. That doesn't mean that they're not equivalent. That just means that I cannot use that strategy. So I need to use my other strategy, the unit rate strategy. Unit rate means finding out how much for one. How much is in one vase. So 42 flowers put into 7 vases is 6 flowers in a vase. And 54 flowers split up in 9 vases, 54 divided by 9, is also 6 flowers in a vase. So yes, they are equivalent. They both have 6 flowers in each vase. All right, for homework, you are deciding on your level and circling your problems. So pause the video and take a minute to circle your problems. And this is due on Friday. Remember that win is only on Tuesday and Wednesdays this week because we have no school. So try to get it done as soon as you can so you can